All right. So again, my name is TJ Yerke, SBCA staff member. I want to welcome you all to today's webinar on lean and lean manufacturing concepts and processes. Before we get started, I want to just administer a quick poll to you all just to gauge who's out there listening today. So the question that we're asking is, have you received formal training in lean implementation? And the simple answers are yes or no. And I'll give it just a couple of seconds. The question is, have you received formal training in lean implementation? Yes or no? All right, I will close it up here. And I'll just share it with everyone. For everyone on the line and for Paul, of course, it looks like 68% of our attendees who filled out the poll have not received any formal training in lean implementation, but 32% have. So that said, let me introduce Paul, our speaker here today. Paul is with Villaume Industries, and he comes to us here at SBCA with a unique perspective, doing a lot of lean concepts and working on lean manufacturing implementation throughout other industries throughout or outside of the component manufacturing industry in our association. So he definitely brings a very unique perspective to this topic. And today, very excited to hear what he has to say. So Paul, I'm going to turn it over to you.
All right. Thanks, everybody. And thank you, TJ, for having me here today. And just really appreciate everybody coming on today. And if you have any questions and comments, feel free to send a note to TJ, and I'd be glad to answer them at the end of this, or you can get a hold of me after. Real quick bio on me. Christian, married for 24 years, have 3 children, bachelor's and master's in industrial engineering, and I've spent 20 plus years of my career in lean implementation. I've spent a significant part of my career at Cummins, 3M, PCC Airfoils, and a few other places. All these places I've spent a great deal of time and effort learning, working with others, developing people, processes, and products to be able to improve the systems. I had the unique opportunity at Cummins to travel the world implementing lean, spent a great deal of time in China, India, Singapore, Germany, England, Romania, and Taiwan. All of them had different issues, but all of them had similar areas for improvement. And it's just taking this time, getting ready for this presentation. I really had a great time looking back at some of the pictures and projects that I did, and kind of wished I had some more of those projects that I lost in floppy disks and overhead projector screens. So we'll get started here. One of the big things that I teach and communicate when looking at lean implementation or any implementation is making sure that you develop people in 2 ways, giving them an education as well as the applications associated. When you're going through seminars in college, you spend a lot of time educating yourself. You don't do a lot of applications, just some small projects. At the other side of it, a lot of times when you don't have a lot of formalized training, you do a lot of random projects over and over again. Some real quick ways to develop yourself inside of lean is using videos. There's a lot of great videos out there today. Toast Kaizen, The Goal, 5S for Your Garage are just a couple of really great tools that people can use to develop themselves and their teams in lean thinking. It doesn't take anything to put these videos on, have a small team, and get yourself going. There's tons of PowerPoints out there as well. and how to implement 5S standard work, do Kaizen events, any number of things to be able to get people educated in lean implementation. If you want to look a little bit further, reading some books, playing some games, a really great book is The Gold Mine. The Goal also is in a book form. Learning to see, Lego game and dice games are just a couple of the great tools to take your team and yourself up that notch. And by putting the education and application together, this really drives improvement inside of your organization. The big three in continuous improvement when you look at lean is one is MUDA, and that's looking at the 8 forms of waste. A lot of us look at this piece and really think about how do we eliminate overproduction, quality aspects, defects, any number of things that these 8 forms of waste highlight inside of our shop or really in any process. Mira is unevenness. This looks like the ups and downs that happen inside of processes. You have a big surge of orders and then a drop. It's just the ebbs and flows that happen inside of an organization. And Mira, and when you're looking at eliminating Mira, you try to balance out the unevenness to get a consistent flow through your system, through your process. Mirroring is the overburdening. It looks at the weight that we all carry when we're doing our work. And this happens to everybody. This happens to the operators on the shop floor when they get a big surge of orders. This happens to the CEO and executives when they feel the weight of orders, the ebb and flow of their business. It's the same weight, just different parts of it affect different people. And we try to balance out and eliminate these 3 forms of waste, MUDA, Mira, and MIRI. Some of the time terms that we look at is value add. This is the stuff the customer is looking to pay for. This is the motion and work that we do that adds value to the product itself. Non-value added times are like the 8 forms of waste, the walking, the waiting, the quality items that happen inside of our process. Anytime we have something that's broken or that we have a defect inside of our design, these are the non-value added activities that we really look at eliminating inside of our daily process. Non-value add but necessary is the motion that it takes to move stuff, to find things. And what we try to do is try to minimize these as much as possible. It's not a lot of times to minimize, to eliminate these steps. We must get a hammer. We need to make sure that we have material moved. However, can we minimize it or reduce it to the level that it takes less effort, less motion, less work to do it? Two of the others is cycle time and tack time. Cycle time and tack time are the 2 big items when you're looking at trying to put a process together. Tack time is taking the total available time that you have in your workday and dividing it by the volume of work that you need to produce. When you look at time, most times you go into seconds or minutes when you're looking at tack time. So if you have a 1-shift operation, there's 60 minutes. In 60 minutes in an hour times 8 hours, you have 480 minutes inside of the day. If you need to produce 100 units for that day, you have a tack time of 4.8 minutes per product. It allows you to look at work in time inside of a volume or inside of a time system rather than looking at it as just, I need to produce 100. It tells you how many you need to produce at every 4.5 minutes or every time step inside of the process. Cycle time looks at the time it takes to actually build the product. How long does it take for us to, inside of this assembly process, to be able to build the product itself? Combining the two, you look at how do you balance your process. On the right-hand side of the screen, you look at the cycle time as A, B, and C in seconds, and across the top, the line across the top is 30 seconds, saying that you need to produce a unit every 30 seconds. So on step D inside of this process, you would not be able to produce enough product because 34 seconds is your constraint of the operation, and you would not be able to produce at the level that it's looking at. Inside of going after continuous improvement, a typical company has a process of, and what you have here is time going across the bottom. You have 1% of your time as value add. The other 99% of the time, it's waiting. It's not moving inside of your process. So when you look at your process, how much time is actually being taken to value added part of the process? You're working on it, that you're actually building or producing something that the customer is looking for. Inside of a traditional improvement, inside of what industrial engineers were originally taught, go after the value add time part of it. Looking at reducing that time that it takes to actually produce the product itself. So what ended up happening is that they would improve the throughput or the time that it took to produce it by half, which was a great improvement inside of the value add step, but all the non-value added time of it waiting to get to that value added step was still there. So you only had a 0.5% improvement inside of your process. When you look at a Kaizen or waste elimination thought pattern, you go after the non-value added activities more than the value added activities. These are the things that really produce the reduction inside of your throughput time. Inside of reducing inventory improves your process, improves your time inside of your value stream. Reducing the quality problems improves the time that it takes to, or reduces the time that it takes to go through your value stream. I've used Kaizen mentality and Kaizen processes pretty much my entire career. And what a Kaizen is using a cross-functional work team, developing a goal, training the team to be able to see what's actually happening, training the people on the tools and the processes that are on the shop floor or inside of a business process. Teach them how to see waste. Teach them how to make improvements using these tools and tools to be able to make those significant changes. And then the big thing is going to the Gemba. And the Gemba is where the action is. Go down there and look at the process itself. See what's happening on the shop floor so that the team, the cross-functional work team, the operators, the engineers, the schedulers, the supervisors are able to all of a sudden see ways of eliminating these wastes inside of the process. And then the big thing is that, as we learned before, that they got the education, and now it's time to apply those tools and processes. The team here, and we're going to go a little deeper on this project. This was the bus bar cell inside of the operations at Cummins when I was working there. Great team. We did a week event, and we had significant results at the end of this project. And we had operators, we had the materials control, we had interns, we had a number of different people working together to eliminate waste. Here is just a quick overview of what the Kaizen breakthrough methodology looks like. As I talked about, do some training, go on the shop floor, analyze it, simulate it, evaluate it, and then make the improvements and celebrate. One of the big items that I learned over time was that the core team gets a lot of in-depth training. So the people that are on the Kaizen team have to get an extra level of training on these tools. The other big aspect or important aspect is making sure that the team inside of the shop, the other people that are affected, get some basic training, a video or two, maybe a presentation, but just to give them some basic concepts so they understand the tools and the process so they're not blocking the improvements that the Kaizen team is driving towards. Data collection. It's really important to grab data. A lot of times we can look at things, we see things, we're looking at our computer, we're looking out on the shop floor, we have some great reports, but all of us need to get on the shop floor and grab some data collection. Spaghetti diagrams are probably one of the easiest things for people to do, and it's extremely powerful. You just watch the flow of either a person or the material through the shop. It's very easy to do, and as everyone understands how if you have a layout of the shop and you're just drawing the movement of a person inside of the organization, you can really make some great improvements just by doing some spaghetti diagrams, seeing where everybody is going and making some improvements. Taking pictures, before and after pictures, and setting standards of the after is extremely important. Videos are also a great tool that you can take what's happening on the shop floor, bring it back to a training room and go over it piece by piece. Time studies are also very important. It is really required. You have to go out there and really get some basic understanding of what's happening on the shop floor and what everybody is doing in a time study type of approach. Just understand as well, everybody hates them. Okay, the person that's taking the time study hates it. The person that's being time studied doesn't like it. It causes a lot of stress. However, it really drives a lot of improvement inside of the organization. Also, looking at how much inventory you have inside of your process, from end to end of your value stream, from what's in the warehouse to what's in WIP, what's in finished goods. All of this matters. As they a lot of times say, cash is king. Your inventory holds a lot of your cash as far as any business. So understanding the inventory will help you to make sure that you're successful in doing your Kaizen, value stream, transformation, any number of your continuous improvement things. And then just identifying waste. Just going out on the shop floor, seeing how the organization is set up and identifying waste is also just very key. Inside of setting up a value stream mapping is a big part of process. And you see here the value stream map as far as the bus bar process which I originally started talking about. Always in the upper right-hand corner is your customer, how the information comes from your customer to your suppliers and through your value stream is the next, your materials control, your scheduler, your suppliers on the other end, and your process, your value add steps are on the bottom side. And this takes information as far as your cycle times, your changeover times, your reliability, how much quality you have. And it's a one-page document that documents your entire system. The yellow starbursts there, or Kaizen bursts as they're called, tell the people where we're going to work, what we want to do, what are the improvements that we see using the training that we have, and how are we going to transform the business. And here you can see that this is your current state. It kind of explains where you're at today. The next step is to create your future state. Kind of says what we need to do inside of our organization to get to the goal that we need to be at. And the goal here was to be less than 2 days throughput time. And we wanted, you know, and again, inside of the way that I look at the operations, 24 hours is a throughput is the time that's used, not just your shift. If you have a 1-shift operation, that is not 8 hours in my eyes. I look at 24 hours inside of my value streams because that is what the customer sees. They don't see 8 hours, they see 24 hours as far as your lead time goes. So when we looked at this process, we wanted to have a throughput time of less than 2 days to build our bus bar to get to our customers. When we started doing the work, we look at standard work. Are people doing it the same way over and over again? And as you can see over on the left-hand side is one of the foundational pieces is standard work to make sure that everybody is doing it exactly the same way. On the right-hand side is a standard work that we used when I was at Cummins. I don't like this anymore. It is very detailed, it's very processed, it's a lot of data. However, it gets too complicated for the individuals to be able to follow. But this is the level of detail that we got to on asking the people to do their work. This allowed for us to analyze every second, every minute that the operator was doing one complete cycle. Here we have our 5S. You know, a Kaizen project or continuous improvement project isn't great until you start getting out there, sweeping everything up, putting things back in place. Every business needs to do a 5S event at least annually. Things change. It's just like everybody doing a spring cleaning. You need to go through your area and look at the operations and say, where does everything need to be? Where does everything need to go? Do we need this anymore? Has the business changed? Going through the process and making sure that things get relabeled, put back in place, allows for us to put the standard back in place. Would we like to do it a complete 5S relabeling every single day? Sure. But that is more of the daily cleanup. That is more of the daily put stuff back in place. But every operation should have at least one annual, if not biannual, improvement. And remember, it's 5S, it's not 3S. You need to standardize and sustain your improvements. And that's where the daily improvements really come into place, is making sure that things are put back, things are cleaned up, and things are organized. Here's a spaghetti diagram that we had of the product of what we called our type 1. And as you can see here, it is moving all over throughout the operation. The bus bars that we created came in from some conveyors or some racking that was just behind the work cell, and it dropped off, we cut it. It was any number of steps inside of the process. And one of the key aspects here, you see conveyor right in the middle of it. That conveyor really wasn't going anywhere. All they really used it for was a table to keep the product. Here was the second product that we made, and you can see the flow of the product through the work cell here. One of the big things that kind of really stood out to me when we created the spaghetti diagram, on the bottom side of on the bottom side where you see a lot of movement, long distance movement, this was an actual work cell where forklifts used to go up and down significantly. So material actually had to leave the work cell, go into the work aisle to the other workstation. You also see here that the people were actually sitting in the aisle to do their work. They were actually sitting in the aisle, and forklifts are going back and forth inside of their work area, causing a significant safety issue. The final layout As you can see in the blue for our type 1, had a nice U-shaped movement through cut, mark, punch, and form and back to the drop zone. Type 2, the green, you can see it is a little bit more complicated inside of the process. It didn't get us to 100%. Okay, the layout here, we are constrained inside of our work area, but it significantly improved the process. We moved the equipment so that the people were actually sitting on the right side in the work cell itself. We got rid of things. We improved the process. We didn't make it perfect inside of the type 2, but it was definitely improved inside of both sides. The other piece that we looked at is scheduling. Always looking at scheduling inside of your process is extremely important. Inside of our process here, our materials control person did a great job. She was new into our business, she was working, and what she did is that every Monday she would drop off the work for the week, which caused all kinds of problems. What ended up happening is that the operators themselves would sub-optimize themselves and grab the specific orders throughout the week and put them in the order that they wanted them done, rather than what was actually best for the customer. At the end of the project, Angie did a great job of bringing down the daily orders. They were able to optimize within those individual orders to get those daily orders out, making it less confusing for the operators. And also when Angie needed to change the order in which it needed to be due, or the order that it needed to be done, the next day she would put that at the top of the list instead of having to go down there and work through 5 days of orders. Here you can see this is the throughput time of type 1 and type 2, and where the line is in the middle is the type 1 product, and the line on the second part of the graph is the type 2. So we had about a 2 to 3 day lead time on type 1 and a 6+ day on type 2. After the Kaizen was done, type 1 had 2 days of reduction and type 2 had 4¼ days of reduction. So when we look at using Kaizen and continuous improvement tools, you can see the dramatic change after doing a 1-week project of just looking at the layout, looking at the inventory, putting things where they belong. Pull systems and Kanban. You know, the big thing with push is you're sub-optimizing. It's not looking at anything other than pushing it to the next step. If I'm an operator and if I have inventory, I'm working as fast as I can to move that inventory to the next step. In a pull system, the people actually work together, and I only move stuff to the next workstation when my customer, the next step in the operation, asks for it. You can have a batch system, you can have inventory inside of the process, but you need to control your inventory creating that pull. Here we have another example. We used to make rotors and stators at Cummins, and here you can see the takt time versus cycle time bar chart. And you can see here that one of the cycle time, one of the sections is over the takt time, which creates imbalance inside of the process, which requires us to go inside of the system and balance out the process to be able to meet the customer's demand. You know, producing so many rotors and stators every day. Here we have a quick example of the process on how it looked. Each one of these was a stator. The stator line was a very complex and old piece of equipment that we had at 3M. And you can see here that there's inventory everywhere inside of the process. There's a lot of waiting, just creating a lot of fake flow. Yes, it was on an assembly line, but there's too much inventory inside of the process. When we looked at the throughput time, there was 36 units on the line. It took 2 minutes to do each one. It took 72 minutes from when it first started to when it got out. Going to a one-piece flow, if you got down to 6 units, times 2 minutes creates 12 minutes of throughput time. So you can see the dramatic change as far as managing inventory inside of the process. And when you create pull, you have the last person in the line release their order, and then material gets pulled through the system. Some of the graphics get a little screwed up here because a lot of these PowerPoints were made a long time ago, but you can see the movement of the whole team working together instead of them working independently with all the inventory from spot to spot. Here are the results of this, dramatic change. Over on the left, you look at the output, and we had a dramatic increase of stators inside of this line. We increased output by 376 parts per week, getting us very close to our goal of 1,600. Well, let's round up and say we met our goal of 1,600. You can see by improving these steps, improving the process, and I didn't go through all of the items that we improved, but you can really see the dramatic change by doing the one-piece flow and driving after using some of these Kaizen techniques. Secondly, on the right-hand side, you see the productivity change. It improved by 18%. Not only are we producing more, but we're more productive as an organization because we're eliminating the 8 forms of waste. I'm not going to have a tremendous amount of time to go into the theory constraints because I want to get into a couple other items, but the drum buffer rope system is an incredible system as how you manage any manufacturing process. The drum is the constraint of the operation. The buffer is the inventory that you keep in front of your constraint, and the rope ties it in together to create a pull. So inside of this process, the buffer is there so that the constraint never goes down. This constraint always needs to have inventory in front of it so that it's able to produce at its maximum rate. The rope ties back to the beginning of the process and says, if the inventory is reduced, the constraint produces some product, you can start building more. I've used this process throughout my career. It's a great way to control your process and really improve your throughput time and reduce waste inside of the process. And I'll talk a little bit more about drum buffer rope when we get into next week's item or next week's topic about using lean inside of the component industry. The other piece that you also look at is the protection in front of the customer. The customer is always the most important person inside of the value stream. So having some inventory in front of the customer allows you to be able to manage changes inside of your customer's expectation. It doesn't have to be a lot, but it does need to be controlled both up and down, just to take away a lot of the unevenness inside of the process. Using a drum buffer rope system really goes after the unevenness and eliminating Mura. Value stream mapping on information flow. This is just an example out of a book. But what I wanted to show here is that inside of an information flow, when we're looking at like design inside of our process, the person that's supplying you the information and the person that you're giving the information most times is the same person. So the customer is supplying you the design and you're supplying the seal drawings back to them. And this just gives you a quick way of looking at an example here of taxes. A person doing taxes and trying to improve it. Okay. Oh, I think I'm a little out of order. I wanted to show you a quick video. I'm not going to probably go through the whole thing, but when we look at value add type of processes, a lot of times you want to minimize it. You can eliminate the value add, but a lot of times you can minimize it. And this video that I'm going to show you on the left is an operator wiring a switchgear at Cummins. I'm going to kind of skip through it a little bit just so you can get the understanding of the process itself. You see the operator starting to take the wire connectors and putting it in. So you can see here the difficulty and the time that it's taking the person to do it. So if we look at the process itself, you keep going here, it's going to take about 2 minutes for them to wire it up. On the other picture here, we created like a harness for it that it actually just goes in. It took a step that we had to do individually at the station, and we took it offline and we created this plastic fixture that allowed it to go very quickly inside of the process, reducing the value add time of the system itself. Oh, okay. Inside of this example, I'm looking at the time. Inside of this example, when I was at 3M, on the picture on the left was the switch gears that had to parallel a generator to the grid. Inside of a switch gear, it allowed a generator and the grid to work together to get them working as one system instead of having the generator working or being on the grid. The lead time to create this switchgear computer system, this system, took 30 plus weeks of lead time, and it was growing. Orders were always late, new orders were coming fast, they had a great product. Jobs had multiple quality issues and everyone was upset. They were having that overburdening. They had MIRI happening inside of their system. We went to the department. It was difficult to hire new people to get them on board. Engineers had multiple jobs, trying to keep the current team. You know, when people are stressed, they want to leave, they want to quit and move on. And there was 20 engineers, 20 plus engineers in this department, and they just couldn't keep up. So we went out to the shop floor inside their desks and started looking at the projects that they had. The next step is we kind of broke it down into 4 unique areas: the hardware, the software, the project engineering, and the integration of the system. We value stream mapped it, we did time studies, we did a lot of direct observation, and of course we did a lot of training with the Kaizen team and Six Sigma team, as well as the other team members. We decided to create an assembly line. Okay, we restructured the team for that. We had 20 engineers approximately. 5 were now assigned to hardware, 5 were assigned to software, 5 were assigned to project engineering, and 5 were assigned to integration. So we restructured the organization to mimic a value stream, an assembly line of information. Inventory, when we started doing this, we had a great improvement. Lead times dropped from 30 weeks to 18 weeks, but we started to have problems between the groups. Okay, we started to have inventory built. So then we looked at it differently. Then we decided to create teams of easy to hard. Okay, and what we did here is that we had the hardware team start early. Then at some point, the project engineers came in, the software team could work in parallel with the hardware team and the project team, and then the integration team was one of the last steps. From reducing it to 18 weeks, we reduced it to 8 to 12 weeks, depending on being easy or hard. We created a pull. We also added a master scheduler to manage all of the team members. A lot of times people only think of a master scheduler as far as the shop. We did the same thing when we were in our design department. I'm gonna skip this. This just kind of talks about project complexity. This was information moving throughout the organization inside of Cummins. And all the different places for somebody to get a generator. And again, the graphics are off a little bit. I know I said I was going to skip it, but in order for us to quote a job, if everything worked correctly, it would take 50 hours for it to move through all the different time zones to make sure that we had every piece. What it actually took was 224 hours on average because of all the quality problems inside of information. When you look at waste, don't just go to the shop floor. You have to look at the information flow just as important as the material flow on the shop floor. A lot of people always ask if, when, should, how. I have done a ton of Kaizen events inside of people that were moving. People always ask me, we're going to move. We're going to move our assembly line. We're going to move to another plant. Should we do all the improvements now? Well, the thing is that you have to understand what you want to eliminate inside of your new process before you move. This was a company that made radiators in China. I went over there and worked with them for 2 weeks on their old facility so we could redesign the new facility that they were building. So always, always, always take time to eliminate waste, no matter when. Real quick on Six Sigma. Six Sigma was used throughout when I was at 3M and when I was at Cummins. It's a very math-based quality tool. There's a lot of meetings, mostly in conference rooms, significant documentations. There is a lot of steps inside of the process that you go through to get to a lot of stuff that I think you can do in a lot easier time using Lean. And having the process of Six Sigma there for people gives the biggest thing that it does is that it requires you to gather data. A lot of people do things on gut instinct. Six Sigma holds you accountable to making sure that you grab data. However, I think they overanalyze that data when driving continuous improvement projects. And the big thing is to always celebrate. The picture up there is when we opened a new facility in Wuhan, China. I'm there with my friend Eric and my friend Xin Li. We worked really hard on a lot of continuous improvement projects in the old Beijing facility, and we did a lot inside of the new facility inside of Wuhan, China. So always take time, whether it's bringing pizza in or something in, to make just to thank everybody for what they did. Lastly, it's 1:45. This is my daughter, okay? Like a lot of kids, they have a tendency to create work for themselves. And so I told my daughter, Emily, OneTouch. She had a tendency to drop her clothes on the middle of the floor. Then I'd yell at her to throw them in the basket, and then she'd kind of miss, and then I'd tell her to put it in the basket, and all the different steps associated with it. So I said, Emily, OneTouch. You'll save yourself a lot of time. So when you look at implementing Lean, think about OneTouch. How can you only touch that tool, that board once in order to complete the task? You know, just thinking about how to remove steps, because a lot of times we create steps inside of our process that are non-value add, like dropping your clothes in the middle of the floor instead of putting them in the basket. So if you think about your team, your operators, how can they only touch that tool one time? And then just a little humor at the end of it. Remember that continuous improvement always starts with me. When you're asking other people to change, you have to be willing to change yourself. You don't have all the answers. You may have a really great idea on how to improve it, but somebody else might help you get an even better idea. So thanks again, everybody. Hope you enjoyed this. Feel free to ask any questions now or a little bit, send me an email.
Excellent. Thank you, Paul, very much. Certainly appreciate you wealth of knowledge and experience outside of the component manufacturing industry for certain. Hopefully, everyone on the line was able to grasp something in a lot of the information you provided. Hopefully, everyone also got access to our handouts. If you'll check out the handout portion of the control panel, today's session is available in PDF form. So I would encourage anyone to type a question if they do have one right now, and I'd be happy to filter that to our panelist here, Paul, today. Hopefully someone does have a question. In the meantime, as hopefully some questions will come in, I want to ask you, Paul, general question. When you look at all of your experience in the couple decades outside of the industry, is there one or two things that stand out the most to you with regard to lean principles, concepts, implementation that you've seen and experienced outside that you're focused on bringing to the inside of the industry, or you're, reshaping, or maybe you've learned a few things that you could have used outside of the industry?
I would say the biggest thing that I would say is to sustain the mentality and the training and the development. Last year, when I first started doing some improvements, I gave some basic concepts, gave them a couple of videos, went through some PowerPoint, and I didn't get to all of the improvements that we wanted to get when we first hit the extremely busy season last summer. And this year, we started all over again. We started to make sure that we retrained, started developing new teams because of the turnover inside of our team itself. Making sure that the new people get the training so that everybody understands the concepts and why we are doing things really help. Secondly, and I'm going to talk a little bit about this week, is that you're going to make changes that don't work. And be honest with yourself. Just because you think that it's a great option or that it's a great improvement, look at it, make the improvement. If it doesn't work, go back to the beginning and see if you can modify it and twist it, because the waste is still there. Just because the first solution didn't work, go back to it again and see if you can find a better solution inside of the process.
Thank you for that answer, Paul. We do have a question from Connor. Question is, what metric do you use for cycle time, tack time for the components industry?
Yeah, it's a great question. When I've been looking at our goals inside of our operation, I've been mostly just looking at board footage inside of our overall output. I haven't come to a great solution inside of getting to the tack time and getting a great way of measuring tack time on a hour by hour or shift by shift time. But when you look at your goal for the day, if you have some sort of metric of you want to do 25,000 board feet in a shift, that might be your goal for the day. You divide it by 8 hours, you have just a little over 1,000 board feet per hour. Are you capable, and then say, all right, how much of that is floors, how much of that is roofs, and making sure now you're getting down to the balance of, all right, now I need 600 board feet an hour of roofs, 400 and some in floors, and then you start to continue to refine yourself down to say what that tack time is, okay? Then you look at how much you're actually producing as far as a process batch inside of the floor. There's a lot of variation inside of our process. So some of the tools that are used in a standard assembly line have to be modified or reshaped when you're looking at large, significant turnover, small runs of products rather than a standard product running through the system itself. It takes a little bit of work to get to that number on a minute by minute or an hour by hour view.
All right, thanks, Paul. Thanks for the question, Connor. Other questions? Please type them. We definitely want to ask them and challenge Paul here today. Paul, while we wait to see if other questions come in, is there one, when you look at your experience again outside of the industry, is there one or two things that really stand out as being problematic within the component manufacturing industry, or that really stands out, I guess, on the flip side, as being more beneficial or easier, and as we talk about lean concepts and implementation?
When I look at the inside of the component manufacturer, I look at us being a great system for theory constraints using drum buffer rope. We're small batches that get turned over very quickly, and understanding your inventory in front of your constraint is a very important piece on how fast that inventory gets turned over. Making sure that whatever your constraint is inside of your process, that you have inventory in front of it, but you have to control that inventory. Having moving inventory, having extra inventory just creates more waste. As they say, overproduction amplifies all of the other waste. So if you have too much inventory, you're touching it too many times. You need inventory in front of your constraint, but minimizing it, managing it is a very important piece. And there's a lot of aspects of how you come to that buffer side in front of your system itself. I would say that you have an organization of people that are very handy. When you look at making some improvements, making shadow boards, making changes, people are extremely handy because they're working with wood all the time. You can make something different or improve something very quickly out of wood rather than just going to having the perfect solution of something that looks perfect with steel or any number of other things. You have capabilities that a lot of companies do not have.
Okay, thank you for that answer, Paul. Our last question we'll field here is from Ronnie. Ronnie's asking, when producing custom-built products such as steel trusses, wouldn't these metrics be more difficult to track and predict?
Just ask the question one more time.
Sure. Looking at custom-built products like steel trusses is what he's asking.
Yep.
Wondering, would these metrics, which you were speaking to a little bit earlier, be more difficult to track and predict? Basically, the metrics you're speaking to with regard to tack time, et cetera, I believe.
So one of the big, using throughput time is always using throughput time rather than, like say tack time versus cycle time inside of these situations is always a good measure as well. When I was running the sheet metal welding and paint operation at Cummins, I had 125 men and women running 7x24 inside of the operation. One of our goals in kind of taking away, that tack time and cycle time on all the different steps inside of the process, we looked at throughput time. How long did it take from when the order hit the shop floor to when it came out? Allowed us a great metric to kind of say, are we managing our process correctly? We knew the constraint of our operation, which was ours was the brake press part of the process. And so we always made sure that we had inventory in front of the brake press, but we looked at throughput time rather than kind of getting into the cycle time and the tack time of each piece of sheet metal or each, structure for our bases of our generators. Throughput time is just a great metric no matter what it is. And any amount of time that you can reduce throughput time through any of your process directly impacts and improves your ability to meet your customers' expectations. So I would say if you can measure throughput time, that would be just as good, if not better, than looking at some of the tack time versus cycle time. Just make sure you know your constraint, make sure that there's a buffer in front of your constraint so that it never goes down.
Thank you, Paul, for that answer, and thank you, Ronnie, for the question. With that, I guess I'll just point out to everyone still on the line, if you want to go to our next slide, Paul. Next week, Paul here will actually be taking part in part 2 of a 3-part lean series, today being part 1, of course, where Paul's going to take a lot of what you heard today and dig into what they're doing at Villaume and some details more specific to obviously our component manufacturing industry. Again, learning and looking at a lot of the concepts he talked about today. So we hope you will join Paul for that. Of course, encourage you to reach out to him if you do have any questions. Certainly has a wealth of knowledge. And I guess, Paul, I want to thank you for your information today, being a panelist, part of our weekly webinar series, and want to thank everyone for joining us today. We hope we'll see you next week and at future webinars.
Thanks, TJ.